All right, welcome back. We finished RIP version 2 and RIP-NG. That was one of the dynamic routing protocols, and we talked about its limitations and how to configure. So now we're getting into EIGRP. Now all these routing protocols that we're talking about, they're considered IGPs. What is that? Interior gateway protocols, which means that they share the same routing table. And this holds even truer when it comes to EIGRP and when we start doing OSPF. Because EIGRP is based on something called autonomous systems. And I think we talked about it previously. An autonomous system number, let me put autonomous system number. Now this autonomous system number can be in the range between 1 through 65,500, and I believe it's 35. That number keeps popping up all over the place. All right, that is how many autonomous systems you can have. For the CCNA, and I know I've said this a million times, I'm going to say it a million more times to engrave it in your heads. For the CCNA certification, which is what you're studying for, ladies and gentlemen, you only need a single autonomous system. So EIGRP is the favorite. I mean, you're taking a Cisco certification. Guess what? They're going to ask you a lot of questions on EIGRP. So, and I think they're still doing the simulation in EIGRP. So one of the main things you need to remember or focus on is that that autonomous system must be the same on all the routers. Okay? Because the test is based on a single autonomous system number. So when you're doing your simulations or your print screens or whatever it is that they ask you or whatever question, you got to make sure that that autonomous system number is the same on all the routers. That is crucial. That is crucial. That's one of the main things they're going to test you on. Okay? Now, EIGRP, they called it the hybrid. Some people still call it the hybrid protocol. We talked about that as well. But now it's considered an advanced DV or distance vector, right? An advanced DV. Let me bring this up here a little bit. Let me put it. You know, let me put it. All right. Well, let's maximize it. Why not? Okay. An advanced distance vector routing protocol, which means it has both the link state and distance vector. Distance vector, we discussed it already. It does have a max hop count of 255. Okay, max hop count of 255, but it is set by default to 100. To 100. By default, you can, you'll be running 100 routers at the time, or you can change it within the EIGRP or router EIGRP configuration and change the max hop count to 255. You can do that. So you still don't limit it as far as how many routers you can have in your network. Not to mention that it can only be only Cisco routers. Only Cisco routers. You can only use Cisco routers. Up to this point, only EIGRP, both EIGRP for version 4 or for IPv6. Only Cisco routers. Now, the algorithm is dual algo, right? To abbreviate, the dual algorithm. Now, because of the dual algorithm, it does do a lot of calculations. Unlike RIP, that didn't pay attention. The only thing it cared about is, hey, how many hop counts, how far away are you, and which direction should I go? Boom, that's it. It will load balance. It will load balance if there's nothing in between. Because remember, what's the shortest point from a source and destination? A straight line. So if it sees a straight line, oh, one hop away, well, I'm going that way. Doesn't matter if it's, a 56K line or what it is. So it's not really paying attention to different things. It's a heavy traffic this way, slower this way, whatever the case may be. It doesn't pay attention to what's going on the network. It just sees, hey, this is the shortest route from point A to point B based on how many routers I got to go through. That's not the case with EIGRP, which is great. EIGRP is based on metrics, based in the sense of which way it's going to send the information. Now, these metrics are calculated, yes, by the dual, but there's something called K values. Now your book tells you there's only 4. There's controversy because there's some say 4, some say 5. You have bandwidth, delay, reliability. Really? Bandwidth, delay, reliability, load, MTU. Now, I've put the older test book, right, with the newer test book, and there's certain things they really don't talk about, and they've taken things out, whatever, but I'm going to tell you everything. Because this one right here, this MTU right there, is what the controversy is. Some people says that it does use the maximum transmission unit. There are questions in the exam that may ask you what's the maximum transmission unit, which is 1500 by default, all right, bytes per second. But what's on is bandwidth and delay. Those are the defaults that it uses, right? Bandwidth, if you're using, let's say in our serials, and we'll take a look at the interfaces when we configure EIGRP. We'll take a look at those interfaces. And we may even create a new lab so you can see how you can manipulate the bandwidth, all right? Where you can go ahead and send it one way instead of another. So EIGRP, based on these K values, it will choose the faster route. So if you do have a straight line, one hop kind of way, but that straight line is, a dial-up, and you have, T1s on the side, it'll choose to load balance across, the outsides. So EIGRP definitely is a very good routing protocol. It is scalable because in the real world, you will have multiple autonomous systems. And why would you have multiple autonomous systems? Because you can maintain inconsistencies within that autonomous system. That's why you would use, not only for organizational and hierarchical, right, very hard word, purposes, but because organization, right? But for the CCNA, we're lucky, we don't have to worry about that. Not that it's that difficult, but definitely we don't have to be concerned with it. We need to be concerned that, hey, it's one autonomous system, and these are the K values that we use. Speaking of, when EIGRP creates what's called an adjacency with its neighbor or neighbors, right? Remember, routers only talk who they're directly connected to, regardless of whatever routing protocol you're going to have. They only talk who they're connected to. So in order for EIGRP to create that adjacency with its neighbor router, it must have, there's a couple of criteria. We'll hit it in there one more time. So criterias for adjacencies. No? I think it's like that. Adjacencies. All right? You must have, first and foremost, same autonomous system. Second, K values. Same. You must have, I should have put identical. You must have the same K values. If you're meaning if on one router using bandwidth and delay and the other router using reliability and load, then boom, it's not going to create that adjacency. You're not going to become neighbors. Okay? And the last thing, and this is really, hello, EIGRP supposedly, you can have different hellos. And those hellos is what makes it a link state, or one of the things that makes it a link state, where it sends the updates. Hey, I'm still here, I'm still here, I'm still here. It doesn't, it's according to your book, these are the 3 criteria that it looks at. But really the hellos are not as important for EIGRP than it is for OSPF. OSPF is very strict when it comes to hellos. They must be the same. EIGRP is very flexible. I think but for EIGRP, the default hello, we'll look at it. I think it's 5 seconds. But again, you really don't mess around with that. They're not going to test you on the hellos when it comes to EIGRP. That's why I tell you, it really, as far as the criteria to become neighbors, your book says it, but reality, EIGRP doesn't really pay attention. It's not that finicky. Definitely the autonomous system, the K values do need to be the same. And these two criteria, the first two that I put on here, these two right here, is something that for your examination, whether you're in college or whatever school you're in or you're taking the test, this is something you need to home in. Okay, you need to home in on that. So yes, EIGRP does have these criteria. So this is something good that it does, that it looks at these different things in order to make a decision, because EIGRP creates something, right? It's not like hop counts. You're going to see something that looks like this. In RIP, when you did RIP, you saw this, right? In brackets, when you looked at the routing table. Where's that thing? Right? You know you're using RIP because you have the administrative distance and it's one hop away. Cool. With EIGRP, it's not like that. With EIGRP, you're going to have the administrative distance of 90, and then you'll have a number, let's say 1, 2, 3, 4, 5, 6. Something like this. Right? That's called a metric. This is the feasible distance. The feasible distance, which became the successor route that now it's in the routing table. So EIGRP uses things, and this is more terminology that you need to be aware of, because EIGRP uses something called feasible, FS, which stands for feasible successor, which means a backup route. All right. You have also something called a feasible distance. The feasible distance is a calculation of the advertised distance of a router to the destination. Okay? Then you have the advertised distance. All right? This is what the router considers. Hey, this is how much it takes to get from point A to point B. You also have a successor. I mean, you can put S. All right, but this is what's called the successor route, let's say. Successor route, meaning has the lowest feasible distance, which makes it to the routing table. All right. Feasible successors, which is the backup route, let me put it up here, remain in the topology table. All right, so you have feasible successors, feasible distance, advertised distance, and successor. I'll put SR, successor routes. All right, let's do that. Successor routes, SR. Successor routes. The successor routes, successor. I won. I go to the routing table. Lower successor. So let's say between these two, let's say they're going to the same place, and you have the administrative distance, and this one is, I don't know, 1, 2, 3, 4, 5, 6. So out of these two, this has a lower feasible distance than this one. Therefore, this metric, right? This one will make it to the routing table, while this one will stay in the topology. Because your topology table within EIGRP will hold all routes to all destinations. They will be there. Because there's one good thing. EIGRP creates these tables for a reason. It creates a topology table. Well, let's do it in order. It creates a neighbor table. It creates, let me do it again. It creates a, I should have done that, right? Creates a topology table. And obviously, it creates a routing table. The neighbor table is information. Okay, I'm sorry I'm looking down, but it's information, info about the neighbors. I'll abbreviate the neighbors it found. Topology table has all known routes. So all the routes that it finds the first time it converges, okay? Let's see if I can bring this up a little bit here so you guys can see that, okay? So it has all known routes. In the topology table, all known routes, good or bad, they're in there. They're in there in your topology table. The neighbor is about, hey, my neighbor router, right? Information about it. The routing table has the best routes to destinations. And what is it based on again? Based on lowest metric. All right, it does its calculations. It looks at the interfaces. It looks at this bandwidth. And it does look at the delay. Now the delay will be a cumulative delay. Now this is a lab we did from previous. And we're going to use it again. From previous, in this lab, there's not going to be any feasible successor or anything like that. It's the fact that it's going to go ahead and it's only got one way to go. It's only got one way to go. So this way and that way. But when you're looking at these, what can I say? Let's look at the interface. Let's say let's pick this router right here. Let me move it this way right here. Okay. Let's open this up a little bit. Just to show you the interface. CISCO. And let's look at that serial show interface S0/0/0 or 1, sorry. All right. There's your bandwidth for that particular one. For that's a WIC 2T. The WIC 2T has that type of bandwidth on there. If it was a WIC 1T, it will be lower. I mean, it will be greater. Sorry. No, yeah, lower. Less bandwidth. And here's your delay. Here's your delay. Now, your book shows you how to calculate that. Do you need to know how to calculate that? If you wanted to, you can. All right. You don't have to. It's not that it's that difficult. You can do it manually. But again, your concern is, hey, the faster the route means the best bandwidth. So if you have a T1 going this way and a T3 going that way, and depending on the connectors that you have and the cables that you have, if it's fiber or if it's whatever it is, it's going to say, okay, I'm going to choose based on this information. The delay is going to be different. So, and the bandwidth is going to be different. So I'm going to make my calculations based on that and send you this way. That's all. That's all it is. That's all it is. But this is where you would see it. And you can see you have your MTUs, which is 1500 bytes, like I said earlier. So keep that in mind. For some reason or another, I don't know which student it was a while back ago during the old examination that they asked a question on, hey, what is the default MTU or something like that. For some reason, it's in the back of my mind. So there's your 5 K values, even though the book now tells you there's only 4. There's 5. Your MTUs, your bandwidth, your delay, your reliability, and your load. Okay, transmit and receive. All right, and your load. So all these things come into play or could come into play when Dual is making its calculations. Remember, these K values need to be the same. So EIGRP does do a lot of things. It keeps track of a lot of things, especially that topology table. Once we configure EIGRP, we'll go in there, and how you look at the topology table is show, here I am abbreviating, show EIGRP topology, or show IP EIGRP topology. Sorry. Show IP EIGRP topology. All right. That command right there will show you the topology table. One of the things that when you're looking at the topology table that you need to be aware of is you see a letter P in front of all the routes. This equals passive. That's a good thing. All right, you want to see it passive. If you don't see it passive, if you see, let's say, active, instead of a P, you see an A. That's active. That's a bad thing, but being active means that it's still looking for routes. And you don't want that because it hasn't found that route. There is a problem. There is a problem if it's still active, that it's still looking for that particular route. You haven't fully converged yet. So one of the things you want to see is passive. That P, that is a good thing. You want to make sure that it is passive, because if not, then there's a problem. There could be, if I were to create an exam, right, I will definitely put a print screen on there, right, for my students, and I will put one that says active. I will make one up, obviously, and I'll say, okay, why can't I get to this network? And I will put A. Oh, because it's still actively looking for it. That's the problem, right? So if everything is passive, then we need to look for other things that could be going on, all right? Because the topology table, one of the things that EIGRP does, feasible successors. You can have up to 8 feasible successors. Wow. And let's go back up into the notes and let's put that in there. You can have up to 8 feasible successors. That is awesome, right? Now, as you get into your other certifications, right, like CCNP, it'll tell you, hey, you want to have feasible successor because if a route were to go down, your successor route, the one that's in the routing table, that link goes down, it will actually look at the topology table looking for a backup route to actually put it in the routing table and then send it that way. All right, so it is good to have feasible successors, but again, not too many feasible successors. Depending on how your design is, it could actually maybe cause loops. So you got to be very careful when you're designing your network that you don't want to have these feasible successors going on. Sometimes it's good, sometimes it's bad. But again, you can have up to 8 feasible successors in your particular network. In our network, we're not going to have any feasible successors. We may do another lab so I can show you, or I can show you on this one, how you can change the bandwidth of a particular interface and make it go in one direction or the other. Okay? So you can see that EIGRP has a lot of things that it's doing. And it converges very quickly. It's one of the faster ones that immediately it converges and creates these adjacencies with its neighbor routers. If it meets those criteria, and it's going to meet those criteria because you're not going to create anything different. Now, just like RIP version 2 and RIP-NG, EIGRP for version 4 and version 6, all this that I talked about is exactly the same. What's not the same is a configuration. You actually do it on the interface by interface basis instead of doing network statements like we're going to do. And that's another thing. It's still a distance vector, ladies and gentlemen. It's still a distance vector and protocol. I'll get out the way so you can see it, but I'm going to write it first because I know I have a full screen and I know I'm so huge that you can't see it. Since it's still a distance vector, I don't care if it's a hybrid or an advanced distance vector, it's the distance vector nonetheless, cannot forget, and I'll put it in quotes, no auto hyphen summary. You cannot forget that command. You can't forget the no auto summary command. It's still going to summarize by default. It's going to send it to the class full boundary. So you must type no auto summary in order for it to work. Okay? You must do that when you're doing for IP version 4. Now, in your examination, one of the things, and this is more of a test-taking skill or advice that I'm giving you, again, based on all the feedback that I get from students that are taking their test. And I've had several students lately that have been going out there taking their test, and they send me an email, call me back. apparently this is, again, the routing protocol that Cisco loves. So apparently this is the simulation that they're running into. It could be different for you. It could be OSPF. It could be RIP version 2. But up to now, it's still EIGRP. Remember, it must be on the same autonomous system number. That's number one. Number two, make sure you advertise the networks that are connected to that particular router or routers. You can have a simulation that maybe you have to go into 2 routers. I don't know. So you have to make sure that in each router, right, whatever you read the scenario, you have 10 minutes per simulation, read the scenario, and make sure that the routers are getting the network that was introduced or whatever the case may be, but it's advertising the correct networks. And then again, same autonomous system number. And it's a class full boundary. Just like I did the 10.000 here, the same thing you got to do. If they give you whatever IP scheme, if it's a class A or a class B, you put in the class full boundary of the address. There's no need to put in the exact network. You put in the class full boundary. And this goes out to certain individuals out there that loved, well, can't you put wildcard mask? Yeah, you could. But guess what? You're not. This is for the CCNA, not the CCNP, not the CCIE. This is for the CCNA. They want to know that you understand that EIGRP will go back to the class full boundary, so that's what you're going to advertise. And do not forget the no auto summary command. I cannot stress this enough because I see a lot of people are making mistakes, not only in the classroom, because they want to do something else. Don't do it. You're going to advertise the class full boundary. So the way that I configure it here is the way that you need to configure it on your certification. All right. Once you get to the real world, once you get to the real routers, depending on whatever that company does, that's what you're going to do. Okay? But for now, you're taking this course because you want to pass the CCNA. So you need to do it this way. I'm very serious on this. It's very important. I've seen things that's like, oh, wow. Okay? Because, again, CCNA specific. All right, anyway. So don't forget about the no auto summary command because it is a distance vector. So, administrative distance of EIGRP is what? What's the AD? All right, administrative distance, because we do have an advertised distance. Don't get them confused. Administrative distance, and I think I already said it a little bit up. It's 90, right? The administrative distance of EIGRP is 90. Since it's 90, it's going to overwrite those static routes that we have on there, and it's going to override the RIP routing protocol, version 2 or NG, because it uses 120. So EIGRP should take over. All right, so let's go ahead and configure for version 4 and see how that looks like. All right, we're going to go ahead and start. And we're going to use the same network. Why, reinvent the wheel? We have IPs already on there for both version 6 and version 4. So all it is just configuring the routing protocol. So let's go to router 1. We're right here. Okay, let's hit enter a couple times. So we're going to go config T. And we're going to go router. This is for version 4. Router, EIGRP. Now we need to pick an autonomous system. Let's hit a question mark just to verify what I said earlier. So there you go. So I'm not wrong. We do have from 1 to 65,535 autonomous system numbers. All right, so we're going to choose one. Let's choose 300. Why 300? Because I like the movie 300. All right, that's why I chose that. So you can choose whatever autonomous system. Obviously, if you're out there in a real world scenario, you want to organize it a certain way, you pick your numbering scheme. It's up to you. All right, so router EIGRP 300. Network. Not nay. Network. 10.000. Same thing. Network. 192.168.1.0. And the famous no auto summary. do WR. Let's go ahead and do that here now for the second router. Let's put this bad boy right up here. And you can see that. Config T. Router EIGRP 300. Same autonomous system. Network 10,000. Well, look at that. We found the neighbor. Automatic. Look at that, how quick it converged. Right then and there. Say, hey, I know you. Okay. And now we're going to go ahead and do the next one. Network 192.168.2.0. And then no auto hyphen summary. Once I do that, guess what? Again, because it recalculates. Because without putting the auto summary, it says, okay, well, I have neighbors that are in the 10, but we actually now, with the auto summary, boom, it faces a certain way. All right, we're going to do WR, because those are the only two networks there, right? It really is 3, but again, classful boundary. And then we do the last one. Enable Cisco, and then we do config T, and then we're going to do router EIGRP 300 network 10,000. Ooh, look at that, found it already. Network 192.168.3.0. Ooh, that's at 30. 3.0. No auto hyphen summary. Do WR. From right here, let's take a look at the show IP route. Let's take a look at the routing table. Hey, look at that. Now we got D's. We got D's for the 10.114. We got a D for the 1.0 network. We got D for the 2.0 network. Outstanding. There's the administrative distance. There's my metric right here. Okay? And I'm learning it again via the 10.119, which is the neighbor over here, on my 0001. So you read it the same, but now it's D. What does D stand for? Dual. If you don't know, take a look at this right here. It'll tell you D, EIGRP. Why not E? Because D means dual. They decided on D. Hey, you got to know. D is EIGRP because of the algorithm. So there you go. We have connectivity now. And it took over because of the administrative distance. You see how important that administrative distance is? Because again, when I do my test, that's one of the things that I put on there. If you're running these 3 routing protocols, and I'll throw in some metrics and I'll throw in some hop counts and things like that and cost values just to throw it off, who will make it to a routing table? Well, the metrics or the hop counts or the cost for OSPF have nothing to do, or has nothing to do, with who's going to make it to the routing table based on the routing protocol. It is the administrative distance of the routing protocol that says you're going to the routing table. And you can control that. You can change the administrative distance of a particular routing protocol. Again, it's completely up to you. So you see that configuration is very, very simple. Now, what we need to understand and get familiarized with is show IP EIGRP topology. This is what we need to know. All the networks are there. Okay? There's your feasible distance to each particular network. All right? You see right there the 856, and they're the same. You see that there's not one network that has 2 routes, because there's only one way to get across. There's only one way to get across. So you're not going to have 2. In order to have that, we will have to have, let's say, a redundant link coming back. But if you had those redundant links, you could then go inside the interface and change the bandwidth and force it to where you want it to go. All right? Okay, so there's EIGRP for version 4. Can we ping across? Let's bring up a PC and let's find out. Come on, PC. Come over here. There you go. Good PC. All right, and let's ping again the version 4 address, 192.168.3.254. That is the default gateway right here, the F00. Let's see if we can ping the actual IP version 4 address. And of course, ARP, right? We missed that one time. Boom. Now we got it. We can ping all the way across. Let's do it again just to get the 4 replies. Awesome. And we're doing it via, okay, EIGRP. Let's take a look at here. You can see that the neighbors that starts the end there, Control Z, show IP route. And you see that this one also has all these. Learning about the 2, learning about the 3, learning about the 8. And again, the administrative distance, the 90, the metric that it's using. And you can see it's the same because we have a straight line going across. That's not going to change. Now let's configure EIGRP for version 6. Now we have everything in place. Now, one of the first things I said for version 6 that we need to do is turn on IPv6 unicast routing. That's already there, so we don't need to do it because we did it earlier when we did RIP. So all we really need to do is go inside the interface. But wait, the first one, let's do it the long way. Because with EIGRP, there's a couple things that you do need to do, and I'll show you. Config T, again, we have to do IPv6, router, EIGRP, and let's use something different. Let's use 100. All right. Now, if I did a question mark, there's 2 things. All right, so we did the IPv6 router EIGRP 100. We know we're going to use the autonomous system 100. But now we have these 2 commands on here, router ID and shutdown. You see that the router ID is for this EIGRP process. This is something new. This router ID, which is based on IPv4 addresses, you have to use the IPv4 address format, is for the protocol instance. That's what it's called. All right, a protocol instance, a process for this particular EIGRP. You must put it in there. You must put it in there. And then you must turn on the protocol. You must turn on the protocol. So we'll go ahead and do router ID. This is router 1, so I'll use that router ID. And then I will do a no shut. Done. All right, at least there. But now I need to go into the interface F0/0, and then enable that IPv6 EIGRP. What is it? 100. And then go to int S0/0/0 IPv6. I'm just going to up arrow 100. So I enabled that autonomous system on those 2 interfaces. And we're going to do the same thing on the other routers. Let me save this, do WR. All right, let's exit one time. Router, oh, I'm sorry. IPv6 router EIGRP 100 router ID. I'm just putting everything the same just for quickness sake. And then no shut. Now I'm going to go into the interface S0/0/1, enter. I'm going to do IPv6 EIGRP 100, build a new adjacency. So, and then F00. All right, so if you look at it, let's take a look at the start, show start. And let me do a do WR, I'm sorry. Do a do WR or WR. So we can look at the start and not to do a show run. But we know the difference, right? We should know the difference. All right, let's take a look at the routing protocol. You see the interfaces. You have IPv6, RIP1 enabled, but you also have IPv6, EIGRP 100. So who's going to take over? You saw that we created, when you saw it, it came up, right? Before. So, okay, so that's in there. Awesome, awesome. And there's router EIGRP for for version 4. And then there's IPv6 router EIGRP 100 with the router ID and no shutdown, meaning it's turned on. All right, and that was, what router is this? Router 2. Let's go to the last router. And we do the same thing. Config T, IPv6, router, EIGRP 100, router ID 101.1.1, and then no shut. All right, to turn on the routing protocol. Interface, let's do the LAN first, F00. Why? Because I don't want to get that adjacency to pop up. IPv6, EIGRP 100, and then interface S0/0/1, IPv6, EIGRP 100, boom, adjacency, Control Z, WR. And if I wanted to take a look at the routing protocol, the routing table, show IPv6 route. Now who do we have? Now we have D. Just like the same thing that happened in IPv4. We have the D in there, okay, for IPv6. Right? We're learning about the 1000, the 1100, we're learning about the 1300, and that should be it right there. All right, so there you go. We have 3 routers running static routes as backup, a RIP routing protocol, so if EIGRP goes bad, RIP will take over. All right, and if that goes bad, we have static routes that are going to take over with the default routes on the stubs. You see that? Now, obviously, you're not going to do this in the real world. You're not going to create 3 routing protocols or 2 routing protocols as backups because you have those algorithms that are calculating, and you don't want that to happen because you're going to burn the routing too much, the processing of the router, right? Not that RIP really does a lot of processing in there, but EIGRP is making a lot of calculations. Not as much as OSPF, but it is doing its calculations, looking at the topology table, creating that topology table, creating show IP EIGRP name for the neighbor. Hey, there's my IP version 4 neighbor, right? Now, don't worry too much about like this right here, the return trip timer, right? How long it took, or the smooth round trip timer. How long did it take it to get around the network? And you can see it's milliseconds right here. It didn't take that long. It's a very small network. So, but know that it's learning about your neighbors right here. Okay, learning about your neighbors. So this is important things. Do you need to know these commands? Sure. Show IP EIGRP neighbor, show IP EIGRP topology, even more important, because guarantee you, let me do an up arrow here and just do topology. I guarantee you, because I would do it on my exam, you will get a print screen that looks something like this of a topology table. You need to make sure that, hey, passive, good to go, right? Found all the routes. I'm not actively looking for anything. If I were to change this, let's say I put it in Word, change it to active, do some different metrics, whatever, change it around, means it's still actively looking. We still haven't fully converged, okay? So that's the problem, if that is active, okay? And again, because it will query if a line goes down, if this will have redundant links to it, it will query the topology table looking for a feasible successor, if a feasible successor even exists, because feasible successors have to qualify to be a feasible successor. All right, so that's EIGRP. That's EIGRP. What do you need to remember? Hey, the terminology of what a feasible successor, feasible distance, advertised distance, and the successor routes are. Know that the feasible successors are backup routes. Know that your successor routes are the ones in the routing table. Know your K values. Know the fact that you have to have the same autonomous system number across each and every router for the certification. Real world, different story. We're not talking about real world. We're talking about in a certification. If you have a small network in a real world scenario, yeah, you can have the same autonomous system. Not a big deal. But as you grow and you expand and you're branching out to different counties, different states, then you may want to start doing multiple autonomous systems. But other than that, using small networks with a single autonomous system, you're not going to kill anything. All right, but these are the things that you need to be concerned with. All right, these are the things. The range of the autonomous systems. All right, the no auto summary that you're going to type, that you're going to advertise the class full boundary. And one last thought, one last thing, okay, just in case, and if you can't see it because as I'm typing it, I'll move out of the way. The passive hyphen interface and then the interface. I'm just going to put whatever. That one right there. If for whatever reason on an examination, school, wherever, okay, you see this, but it's pointing to an interface, let's say that's going out to the internet, don't worry about it. You don't want EIGRP to send out updates out to the internet. Now, if this passive interface, it's pointing to an interface that's to networks within, internally, right? That you want these routers to know about these networks, then that's a problem. Then you will need to go inside the router EIGRP or IPv6 router EIGRP, whatever autonomous system it is, and put no passive interface, whatever interface that they're using. But if it's pointing to an ISP, if it's pointing outside the network, don't worry about it. One of the things in your certification or your exams that you do in your schools, one is a hands-on thing, and you're dealing with routing, make sure you can ping. You sit on one router and you start trying to ping the others. If you can ping every router from where you're at, then you don't have a problem. If you can't, then you better fix it. Now remember, in your certification, you got 10 minutes per simulation. But once you hit that next button, you're done. You're not coming back to that question again. So you got to make sure that you can ping. And now what I'm telling you now is, make sure you're in the same autonomous system. Make sure you advertise the classful boundaries. All right? Remember, when you're doing dynamic routing, you advertise the networks that you are connected to. You advertise the networks that you are connected to. And it's the class full boundary network, just like we did with the class A, 10.0.0. You didn't see me put in individual networks. So that's the same thing you would do. All right? So make sure you do that. Same autonomous system and advertise the class full boundary. And please, again, once again, do not forget the no auto summary. Okay? All right. There's EIGRP. It's not difficult to configure. Just remember those three things that I just told you about. All right. Oh, and yes, passive interface. If it's going out to the internet, forget about it. If it's facing internally, then you take it out. You go inside the EIGRP process or router EIGRP, whichever, version 6 or 4, and just put a no. No passive interface and whatever it is, and you'll be just fine. Okay? All right, ladies and gentlemen, that's the end of this lesson. I'll see you in the next one.